Hello everyone, welcome to class and just give me 2 minutes. I will just check if I'm live streaming and we will start the class. Okay. Alright, sorry about that. Let's begin. Welcome back to the class. So today is the fourth class in the electrostatic series that we started. And once again, my name is Mohana. I'm a physics educator at Unacademy. And I'll be basically taking your class 11-12 ISC boot physics. Alright. So here I've shared my Telegram group link. So you can join in my link. This is basically my personal group Telegram group link. You can join this link, and before taking any classes, I would basically be sharing the invite. Basically, be sharing the whatever upcoming classes are there. I will be sharing in this group. Also, there will be if you join this class, if any updates that are there, I would be sharing the same as well in my personal group. Similar to that, we also have another Unacademy channel. So this Unacademy ISC and ICSE and ISC board, this link is common. Right, this is the common channel that you can follow as well. Now, just like how we have free classes in the Unacademy in the YouTube channel, similar to that, in the website as well, we have free classes. So those courses are called as special classes. So these happens at Unacademy website. You can take any special classes for free from your favorite educators. And we have a particular interesting feature called as the pool. Here you can actually, the educator will ask you, like let's say you're learning a concept. So today's concept is electric field. So by the end of the class, there would be in the class, there would be questions based on this electric field, that lines that are asked as poll. So as you answer the question, you'll come to know whether you understood the concept well or not. Okay. So that is the purpose of your this is the purpose of your field. Shurya Garwal, when will I start with class 11? Yes, Shaurya, the class 11 we would start from June 8th onwards. So you mean class 11 for plus batches. I hope you're talking about the plus batch. So that starts on the Unacademy platform on June 8th onwards. Right, I'll share you the same information by the end of the class as well. Okay, and Priyanshi, is this for the 2023 batch? Okay, this is for the batch that is starting on the basically if you're starting your class 12 academic year from class 12 or class 11 academic year from this next month, June onwards, then obviously you can follow this class. Okay. Now, again, other than this, the free class is also a live class. So any doubts you can you can ask in the free classes as well. Now, if in the next month, whatever upcoming free classes I have, I would share the same. Now, other than the free classes, the next option that we have is, okay, hi, right, hi, I could see you, right, Sasi, right, okay, hi, you're back in the class, and okay, and other than the special education, other than this special classes, we also have the plus classes. So in plus classes, basically these are paid, these are in the plus batches, right? So you can actually learn from the comfort of your home. You have access to unlimited content, and again, all the educators are really good, so you will be learning from the top educators. And other than that, you have any courses that you're starting, right? Any plus batch, the fourth session is always a doubt clearing session. So if the class starts today, fourth class from today is a doubt clearing session. So any doubt you have in the last 3 classes you have learned, you can ask in those doubt clearing sessions. Okay. Now other than this, in your Plus subscription, there was an exhaustive, we would be covering your entire syllabus. Now every weekend there are also some live test series. Okay, and those live test series will basically be based on these, let's say every week you take there would be some test series for this Plus batches. You can take the test, and after the test there will be there would be analysis for the test session as well. And we also have new batches coming up, so stay tuned to know the same. You saw the physics. Okay, I saw physics for class 11 will start from tomorrow. Actually, you mean the YouTube classes for class 11 has already started. Okay, and the special classes for class 11 and class 12 are simultaneously happening, right, in YouTube as well as in the Educator platforms, right, sorry, in the Unacademy platforms. Both classes are happening, and Plus batches are currently going on for class 12, and Plus batches for class 11 will start next week. Next week onwards we would have the Plus batches for class 12 starting as well. Okay, all right. Okay, okay, you're really excited. Okay, that's really nice. All right, now okay, now again, so the course the course pricing. So as you take for more number of months, as you increase the duration of the course that you're taking, then the pricing of the course also decreases. Okay, and anytime you're taking a Plus subscription, if you're using my code MTIS10, whatever the price is, for that price you would be getting a 10% off. Okay, now with that note, let's go back to the class from where we left in the last class. So last class we covered the concept of, we basically looked into the introduction of Coulomb's force. Actually, we revised the introduction about Coulomb force, and we went ahead with what is an electric field, right? So in today's class, we would basically be starting with, okay, in today's class we'll just see a small introduction of what is the electric field, and we will see what do you mean by continuous charge distribution. Okay, so Coulomb's law of force, basically Coulomb said if you have two charges separated by a distance, right, if you have 2 point charges, right, Q1, Q2, let's say these 2 charges are Q1 and Q2, if they are separated by a distance, right, let's say the distance between them the R, then the force between these two due to this charge, okay, you would, and force on this charge due to this charge, so you can get the magnitude of the forces. Now if you take the same force, they have the magnitude, you're not changing the magnitude of the charges, or you're not changing the magnitude of the distance between them. But if you take this same force and if you change the medium in which they are kept, first you kept in vacuum, now if you keep in water or any other medium, what happens? The force value changes. So what is changing that force? Right, then that is the constant K, that over here, the permittivity that you're seeing, right, the permittivity of the medium, that changes, because of which the force as well changes. This was the basic introduction for force. Now, if you have taken yesterday's class, can you tell me electrostatic field is what? Is it option A, B, C, D? Electrostatic force, is it force per charge, or is it force times charge, or is it force charge per force, or is it none? Which of the options is right? Electrostatic force, electrostatic field. Okay, so if you look at electrostatic field, right, electrostatic field, if you want the field, electric field is basically given by force experienced by per unit discharge. Okay, so your electric field lines E is basically given by force per charge. Okay, that's your right answer. All right, now very simple, you have a source charge, let's say this charge is positive, so this positive charge will have field lines going in all directions. Let's just say there is a field line going in this direction over here. Now I want to actually find whether there is a charge, if there is a charge, if there is a field around the charge. Okay, why do we need to define this field? Because what is, when you keep 2 positive charges, right, if you keep 2 positive charges on with the particular distance, we can see these charges repel each other. right? What is making these charges repel each other? That can be understood by this concept of electric field. Okay, so now if you basically introduce a, let's say in this place I'm introducing a test charge. Okay, it's a test charge with Q0. Now if I introduce a test charges are always positive unless until specified. Now what will be the force experienced by the test charge due to this test charge over here? The force experience, this will basically repel, this positive charge will repel, this is also a positive charge, right? This will repel this charge in this direction, right? The force experienced by this charge due to this charge will be in this direction, so that's the direction of your force. Okay, now because you're keeping it, the force, the charge is getting repelled. From there what we can say? We can see that there is something in that medium which is actually making these charges repel. So that is nothing but your magnetic field. Sorry, that is nothing but your electric field. So electric field E can be given as force experienced per test charge Q0. Hello Daksha, right? Force experienced per test charge. That is basically your electric charge. Now this the direction of this electric field lines in this case is as the same as the direction of your force as well. Okay, now let's see. Let me just give you a question. Okay, let's say I have a plate. Let's say this is my external plate. Okay, let's say this is negative, this is positive. Okay, now let me change the sign. Actually, let's say this is positive, and let me say that this side is basically negative. Okay, now this is the external force. Now the charge is, right, whenever you take any charge, for a positive charge it is seen that the electric field lines go outside. For the negative charge, the electric field lines will basically come inside. Okay, they're radial. So the electric field lines go in this direction from positive to negative. Okay, now let me consider a uniform electric field. Uniform electric field is nothing but the direction of the field lines are same, and they go from the spacing between them, no, the spacing between the same them is also same. Okay, they are in the same direction as well. Okay, so in such a place, if I keep a, let's say if I keep a positive charge, can you tell me in which direction the charge would move? What will be the direction of the force experienced by this charge? And if I keep a negative charge now, same electric field, if I keep a negative charge, what will be the direction of the force? What will be the force? In which direction will this charge move? There is an electric field line. There is an electric field. In the electric field, I am keeping a positive charges. Right? The positive charges will always move towards this side. Okay? And the negative charges will move towards this side. Why? Because you have applied an external field. Right? You have given some sort of supply where this terminal is basically positive, this terminal is negative. Why? Because this terminal is positive means the electric field lines will always going for a positive side. They are always pointed outwards. For a negative side, they are pointed inwards. So they go from start at the positive and go towards the negative. That's the direction of your electric field lines. Now, if you keep a positive charge, what happens? It will move towards this side. Why? It is going towards this negative plates over here. As in, if you keep a negative charge, the direction will go in the opposite direction. Why? It's attracted towards the positive charge. Okay, I hope this concept is clear. If you don't, again when we are doing lines of forces, you can ask me the same question and I'll explain this. Alright? Okay, now electric field again is a vector quantity and it's just force per unit charge. So since it's force per unit charge, its unit is Newton per Coulomb. This is what we covered till yesterday. And then we covered what is a superposition principle. Superposition principle is very easy. Now, superposition principle is there for force as well as electric field, right? So if you want to find what is the total force acting on one charge because of a number of charges in the system, right? That will always be the addition of, so the field lines over here, it will always be the sum of all the individual charges, right? So this is something we covered in yesterday's class as well, right? If you want to find out. Okay. So if you want to find out what is the field due to the other, due to all charges, right? So this will basically be this force. experience, total force experienced by one charge, okay, any charge that you're taking, okay. If there are a number of charges around, right, let's say there is charges and let's say there are a number of charges around, and you want to find out what is the force experienced by this particular charge over here. The force experienced by this charge will be because of this charge, this charge, this charge, all of these charges will act a force on them, no? So the force acting on this charge is given by the superposition principle. So in simpler terms, we give it as what? The force experienced will be basically the force experienced by this charge over here. Let's say that this charge is Q naught divided by 4 pi epsilon naught. Okay, that's the charge that I've taken. Summation, right? Summation here, let's take I is equal to, sorry, just a minute. I is equal to 1 to n. Okay, here this will be Q1, right, Qi. Now if it's the force experienced by the second charge means this becomes Q2. Alright, force experienced by third charge means this becomes Q3. Force experienced by first charge means it becomes Q1. Okay, Q1 by R, force experienced by this, okay, instead of the zero charge, let me actually take this as the first charge. So this will become 1. So this is 1, this will be 2. Right, so force experienced by the first charge into 1 into this vector, into the R1 vector. This becomes your force equation in case of superposition principle, which we did in the last class. Okay, similar to force, which has a superposition principle, we also have superposition principle for electric field. The principle of superposition for electric field says that the electric field at any point due to a group of charges is always equal to the vector sum. Okay, at any point if you want to find what is the force on one particular charge, there is a charge over here. Let's say there are multiple charges everywhere. Okay, let's say there are multiple charges everywhere around in this place. Okay, now I want to pick this point. At this point, okay, I want to see what is my electric field. The electric field at this point will be because of this first charge over here, that is E1 vector, the electric field because of the second charge, that is E2 vector, right? The electric field because of the third charge, and so on up to the electric fields up to the nth charge in that place. Now how do we write this in common term? How do we write it in a generalized form? We write this electric field as 1 by 4 pi epsilon naught. Okay, 1 by 4 pi epsilon naught. Here it will be again summation. I is equal to 1 to the power n. Right, then this will be Qi divided by Ri square into Ri cap, because the equation, the magnitude equation of electric field is what? 1 by 4 pi epsilon naught Q divided by R square. This is the magnitude equation. This will be the vector equation. In this case, vector equation. At this point, what is the electric field? Because of all these charges will be given by this equation. Okay, this is something we learnt in the last class. And if you have any doubts, you can go further that class video, or if in case if you still have any doubts, you can ask me. All right, I'll be there too. I'll explain this once again. Okay, now till now whatever we saw was because of one. We were basically looking at charges, but whatever charges we considered, even if we took 2 charges or n number of charges, we were just looking at one specific charges. But usually we deal with charges which are much greater than magnitude than the charge of an electron, right? So you can actually think of the charges actually being spread in a region. Let's say these charges are continuously spread in a region. Every point on the surface has a charge. Okay, such a charge is called as continuous charge distribution, right? If you look at a wire, okay, any wire, any cable wire you're looking at, everywhere on the wire there are charges, or there is an electric charge, that is electrons or free electrons that are there. So everywhere on this wire there are charges. So we can say that for charges are like continuously arranged. Take a sphere, there's charges everywhere. You can take a paper, you can take a small bit of paper, and you can say there are charges continuously spread everywhere around. Okay, so this is basically called as this taking these charges, because that's how we deal with, right? We just don't deal with 1 or 2 charges, right? We always deal with charges which are basically in much greater in magnitude. So we can imagine these charges to be spread in a continuous manner in region. Okay, such a distribution of charges is called as continuous charge distribution. Now, because of a continuous charge distribution, what will be the force acting on a charge. Okay, for example, here let's say this is a surface. Okay, let's just take an uneven surface. Okay, over here, everywhere around this charge, right, everywhere around here, right, everywhere around the surface there are charges. Continuously everywhere charges are there. Now we want to bring in, okay, now what we are going to do is we're going to bring in a test charge. We are going to bring in a test charge. Let the test charge, let's keep it test charge which is basically Q0. Okay, this is over here. Now what will be the force experienced by this discharge because of this continuous charges over here? It is because of this continuous charge distribution. To find this, what we are going to do is, first we are going to take a very small region of space in it. Okay, let's take a very small region over here. Okay, now this particular region over here has, if the continuous charge over here, let's say the continuous charge over here is Q, continuously, this blue region that I've drawn, okay, all of these charges is equal to Q, means the small area that I've taken, that charge will basically be dQ. Continuous charges is Q, the small area that I've taken, that charges will be dQ. Alright, so from here we can say what will be the force, right, acting on this charge. Okay, from here to here, from this small area that we have considered to this charge over here, there is a distance, right? This distance we will give it as the R vector, position vector R vector. Now, what is the force acting on this charge dQ because of the small area we have considered from this charge, right? That we will basically given, that will basically be given by, that is your charge, okay, that is dQ, right? Sorry, that is basically right now we want to find the force, right? Now the force acting on this charge because of the small area, right, not because of the continuous all of these charges, but we have wanted only because of the small area force over here, that will be dF. Why dF? Because we are considering only for a small region of the charges. Okay, so this dF will be equal to, what is the force equation? It is equal to 1 by 4 pi epsilon naught, the point charge is Q naught, into what is the charges in this area, dQ, divided by what is the distance between them, R square. In terms of unit vector, we use a unit vector as well, right? In terms of, if you want to write this in terms of a vector equation, because we know R vector, right, the unit vector is nothing but R vector by R. This is a unit vector magnitude is just 1. Okay, this is your vector equation. Now, this is the force, this is a force acting on this charge because of the small area. Now, if I want to find what is the force acting on this charge because of this entire surface, what will we do? Then we have to integrate the whole surface, because integration means what we are actually doing is we are taking a very small surface, similar another surface, that is again another dq. Again we are taking another surface, another dq, another surface, another dq. Similarly to this surface we are taking all surface other surfaces also over here. Because we are taking a similar quantity of charge and the distance from them is also same, it will basically be adding these. We are you're basically adding the same quantity of changes multiple times. In such a case, we can use in such a case you can actually integrate the whole equation. So basically you will integrate df, okay, and you will have to integrate this entire equation. So integration of df is nothing but f. You get, when you integrate this df, right, this force, basically you're finding what is the force because of multiple small dq charges over here on this point. Okay, so if you're adding all of them, you will get the force, the complete force acting on this point because of this charge q. Okay, that force will be integration of df is equal to 1. This again we'll remove the constant quantities. 1 by 4 pi epsilon naught is constant. Okay, so basically this this will be basically integration of 1 by 4 pi epsilon naught q naught dq divided by r square into r cap. Right. So if we remove the constant quantities, right? Let's remove all of the constant quantities. If you're removing the constant quantities, then q naught is also constant, so we'll remove that and we will integrate only this. Okay, so this basically, if you integrate f, right, you will get q naught divided by 4 pi epsilon naught, that's the constant quantity, integration of dq r square into rf over this entire area, okay, will give you the force. Now this equation over here will give you the force acting on this charge because of this entire surface. I hope this is clear. So this is your continuous charge distribution, and this equation gives you the force on a charge due to continuous charge distribution. So this is your equation for force on a charge due to continuous charge distribution. Alright. Now this continuous charge distribution, there are of 3 types. Okay. So the first, right. So if you have any doubts till now, you can ask me in the chat box. Okay. So the continuous charge distributions are of 3 types. The first is basically volume charge distribution. Right. The next is surface charge distribution and also linear charge distribution. For all these 3 cases, let's actually find the equation for electric field, force experienced by a charge because of linear charge distribution, surface charge distribution, and volume charge distribution, and also what will be the electric field line. Alright. So first let's do linear charge distribution. It's very easy. If your charge distribution is along a one-dimensional curve or line in space, then it's linear charge distribution. Think of the charges. If you take a wire, how are the charges moving? They are going in one straight line, right? You can basically take it as a charges going in one straight line. So that is basically your linear charge distribution. Okay. So here you can take like a wire, right? This wire has positive charges everywhere. Let's take this wire has charges. Let's take it to be positive charges, right? This wire has charges everywhere on its surface. Okay. Now, because of this charge, I want to find out, I'm going to introduce a test charge. Right? We're going to introduce a test charge somewhere over here, and let that test charge be Q0. Now, because of this wire, this linear charge distribution, right? Because of this wire or anything that you're taking, because of the charges on that wire, what will be the force acting on a test charge that is over here? That's what we want to find. So, your linear charge density at any point on this line, at any point if you want to derive the linear charge density, it's defined as the charge per unit length of at that point. And linear charge density is given by the symbol lambda. Okay, so this is given as lambda is equal to linear charge density at any point that you're picking. Let's say at this point, at this point I want to know what is my linear charge density, right? I introduce a test charge at that point to study it. So the linear charge density at any point on this line, okay, sorry, the linear charge density at any point on this particular line. On this particular line, if I want to find what is the linear charge density, okay. So in that case, if I want to find my charge density on this line, let's say I want to find out what is my charge density at this particular region, then that is basically given by, right, that is given by how many number of charges are there. If the complete charges is Q, how many charges are there in that small area is given by dQ, by the total length. Let's say the length of the wire is L. Okay, let's say the length of the wire is L. The total charges in them is Q. So if I take a very small region, okay, and so let's say this length over here, this will be DL. The complete wire length is L. I'm taking a very small segment of that wire. That length will be DL. And the charges associated with the surface will be dQ. Okay. So the linear charge density, the charge density at any point, linear charge density is given by lambda is equal to dQ by dL. That is charge, how much charges are there per unit length at that point that you're taking. Okay. Now, we know what is, now we have defined what is linear charge density, right? Now let's find what will be the total force. So from here, if I just want to find dQ, from this equation, if I want to find how many charges are there in this area, then what can I do? This is nothing but lambda, the value, the linear charge density value, times dl. Okay. Now, so the charge contained in the small length dl, the charge, how many charges are there in the small length, in the entire wire of length? Okay, let's say it's a finitely long wire, and for this, in that wire, I want to find out how many charges are there in the small length. Now that dq is given by lambda into dl. Lambda into dl gives me how many charges are here. Now, what will be the electrostatic force experienced by this test charge that we placed over here due to the entire length of the wire? Okay, so if I want to find what is be the entire length of the wire, I can find out what is my force because of this particular length. So let's say this is basically at a distance, right, from here. Let's say this charge is at a distance r vector. Okay, if I want to find dq, my dq is nothing but lambda. Dq is how many charges are over here, that is lambda d into lambda l. Okay, now here if I want to find out what is my force, what is the electrostatic force at this point because of the small length dl, okay, that is given by df. This is in this case of linear charge density is basically given as we can give q naught divided by 4 pi 1 by 4 pi epsilon naught. We can write this as 1 by 4 pi epsilon naught. Okay, q naught dq divided by r square r cap, right? But in this case, what is dq? dq in this case is given as lambda into dl, right? So your linear charge density because of the the force acting because of this length dl is nothing but 4 pi epsilon naught q naught. dq is nothing but lambda into dl divided by r square into r cap. Okay, now because of the small region, what is the force we have found? Now because of this entire length of wire, right, what will be the force acting on q naught because of this entire force length of the wire? For that we have to integrate. Okay, now if you integrate this equation, if you integrate df, right, you're integrating 1 by 4 pi epsilon naught q naught d l, right, this is q naught lambda into dl lambda into dl divided by r square into r cap. So here, okay, here you have integration of df is what will basically give you, if you integrate because of the small area, this is the force. Now if you want for the entire area, right, if you want for the because of the entire length of wire, because of the charges that is there in the entire length of the wire, because of the total charge q of this entire length L, what is the force acting on this charge? We have to integrate in that case, right? So integration of df will give you f, right? And you can take all the constant quantities outside. 1 by 4 pi epsilon naught is constant, q naught is also constant, you can take those outside. Now this becomes integration of lambda by r square into dl into r cap. Now you are integrating it over the region L, the entire length of the wire. You are integrating it over the entire length of the wire. Okay, now this becomes your force equation, in this case linear charge density, so we are writing L. Now what will be the electric field, right? Because of all of these charges on this wire, right, because of this all of these charges on this wire, what will be the electric field at this point? If you want to study the force also, that point, whatever that point is, we introduce a test charge. If I want to study the electric field, again we are going to introduce a test charge only, right? And what will be the electric field in this case? Right, can you so electric field in this case, electric field experienced by the point charge at that point will be the force experienced that by that point charge by unit force per unit charge, right? Force experienced by the charge per the unit charge, right? Force experienced per unit charge, that will give you the electric field lines. Now this entire equation, if you divide by q naught, what will happen? Q naught will cancel. You will get 1 by 4 pi epsilon naught. Then you basically have integration over L lambda by r square dl r cap. This becomes your electric field. This is electric field due to continuous linear charge distribution. This is electric field due to force due to the linear charge distribution. Okay, so we have done one quantity. If you have any doubt, you can ask me. Otherwise, I'll move ahead with the next one. Now, next concept is surface charge density. linear charge density was one dimensional. Surface charge density, surface charge distribution is basically the charge distribution over a two-dimensional space. Okay, so in this case, the surface charge density at any point on this on the surface, right? If you're giving a surface charge density, you can, so for surface charge density, you can take something like, let's say you have a, if you have a spherical semiconductor, right? Then you can say the surface, okay, if you're taking what is the charges on a spherical semiconductor, then that basically becomes your surface charge density. Okay, now let's say you have a particular surface, right? This is two-dimensional surface, and let's say there are charges everywhere around on this surface. This is not line, this is two-dimensional now. Okay, now the surface charge density is given by sigma. Okay, this sigma is nothing but the surface charge density at any point on this particular surface. Okay, if I take a small surface over here, let me say in this whole thing I'm taking a small surface over here, then my surface charge density will be how many this entire surface over here, right? The entire surface, since it is surface, let's say the entire surface is basically S. So this small surface that I've taken is ds. Okay, now let's say there is a point charge that is somewhere over here. Okay, now because of this surface, what is the force experienced by this point charge is what we want to study. For that, first we have to understand what is surface charge density. Surface charge density is given by sigma, and on, let's say there is a surface S and that has charges on it. Okay, now surface charge density is defined as charge per unit area. Okay, charge, that is how many charges are there, right, per unit area. So that you can give it as, in this case, let's say there are q amount of charges. On this surface over here, there will be dq. The charges on the surface will be dq, right? dq, that's the amount of charge per unit area. But in this case, it will be per unit surface. It's per unit area. This will be per unit area. Now we are taking area into consideration. Entire surface is S, but it's not length. We are talking about area. Area will be ds by ds. Okay. Now, linear charge distribution. A simplest way for you to remember linear charge distribution is think of right. You can think of the electric pole lines that are running, and imagine birds are sitting on it evenly spaced. That's sort of like, birds are sitting on the wire of lines, right? That's basically a linear charge density, linear charge distribution. Now, imagine you have a surface, right? And if you just put some seeds over here, there'll be so many birds coming in to sit over here, right? To get the rice, whatever feed that you're giving, right? If you see a lot of doves spread basically over an area because you have like, some food, some sort of food that is put, right? So if there are like a lot of birds sitting in an area, not on a line, but in an area, you can remember that for surface charge density. Okay. Now, now this surface charge density that you're seeing over here, right, dq by ds, right? Now, if I want to study what is basically my, sorry. Okay. If I want to see what is the force experienced by this charge or because of this entire surface, then what I am going to do is, first we are going to take a small surface, and we're going to see from this surface, okay, from this surface, because of the charges on the surface, what is the force experienced by this charge over here. Okay, let's say the distance between them is basically r vector. Now, the entire surface has charge q. How many charges are there on this surface, the small red surface that I've taken? That dq amount of charges can be gotten from this equation. That is basically, this dq would be the surface charge density into the surface that you consider ds. Okay. Now, what is the force acting on this particular, the force experienced by this test charge, okay, due to the small region? So that force is basically df. This is basically equal to, in this case, again it will be 1 by 4 pi epsilon naught, right? Q naught into dq divided by r square into r cap. What is dq over here? We just define dq as sigma into ds. You can get the value of dq by knowing the surface charge density into ds. Okay, sigma into ds. Alright, now from here, this is the force acting on this charge because of the small surface. If you want for the entire surface, because of this entire surface, what is the force acting on this charge? You have to integrate. Okay, so you're integrating this surface over the entire surface. So if you do that, you will basically get the force acting on this entire because the force acting on this charge because of this entire surface, which is basically equal to, right? This will this would basically be, you can take all of the quantities which are constant outside. Q naught divided by 4 pi epsilon naught is constant. Integration over the surface S, Q ds divided by r square into r cap. That becomes the equation of your force. Now, at this point, because of all of the surface charge densities, because of this entire surface, right? What is the charge at this point? Is basically given by what is the force experienced at this point by a test charge is given by this equation. Now, if I want to find what is my electric field, what is the electric field strength at this point because of this entire surface, then what will I do? Electric field strength, right, in this case is given by, electric field is force experienced per test charge, right? So equation of F is what over here? We know this is nothing but Q naught divided by 4 pi epsilon naught, integration over the surface S, right? Then you have sigma divided by r square into ds into r vector. Now the whole of this equation divided by Q naught. So this Q naught, the whole of this equation divided by Q naught. Now this Q naught and Q naught will cancel. So basically what you would have is 1 by 4 pi epsilon naught. So this gives you the electric field, at this particular charge because of this entire surface. So this is the strength at this point. Okay. So this is basically about your surface charge density. Now again, if you have any question, ask me in the chat box, or ask me in the chat. And right, similar to this surface charge density, the next quantity we have is your volume charge density. Okay. For volume charge density, volume is basically when the charge is spread over a three-dimensional volume of space. Think of a sphere. Okay. Now, everywhere on the sphere there are charges. Okay. Now, this is basically your volume charge density. Okay. Now, to study that, okay, let's if you have a sphere, we are just going to take a small region of the sphere and then going to study. Okay, so let's basically imagine that I'm going to look into a small region of my sphere. Okay, let's say this is my sphere and I'm taking into a small region. So I'm drawing a two-dimensional image, but this is basically a sphere. Think of a ball and there is charges everywhere around, and you want to study. If you bring in a test charge, because of the sphere, the charges that is distributed evenly over the sphere, the charges are distributed evenly over the sphere. What is the force experienced at a particular point? Okay, we study that by introducing a test charge. Right, now to understand what is volume charge distribution at any point in this in a volume is defined as, volume charge distribution is again given by the symbol rho. Okay, this is basically then this rho, if you have an entire volume, let's say everywhere there are charges. So if you have a sphere, everywhere around the sphere you have charges. Okay, now so the sphere has a volume. Okay, the total charges in them is Q. Right, but now to study what is the volume charge distribution because of this entire sphere, what we are going to take is, we are going to take a small region over here. Okay, let's think of like a cube, a small cube. Okay, a region over here. Okay, and this region, the entire sphere has a volume V. So this particular region that we have taken, a small square, the cube that we are taking, that has a volume dV. Okay, now again, let's say again, if we want to study because of the sphere, what will be the force experienced? We have to introduce a test charge. Let's introduce a test charge somewhere over here. Let the test charge be, let's introduce a test charge somewhere over here, and let this test charge be Q0. Okay, now we want to study the force experienced by this test charge at this particular point. What is the force experienced? So study that, we introduce a test charge at that point. Now we want to study because of the entire sphere. Similar process as we did earlier. Okay, now from the center, now from here, again, right, so from the center, from this plane to here, the volume is basically, the distance is basically given by r vector. All right, now and your rho, the volume charge density at any point, on any point on the sphere, if you want to find out what is the volume charge density means, that is basically given by the charge contained per unit volume, that is dV at any point. Okay, how much charge is there? Sorry, how much charge is there per that volume? So the entire charge is Q. So on this, in that small area that we have chosen, the charge is dQ. Okay, and the volume, the entire volume is V. The small volume that we have chosen is dV. So this basically gives you your volume charge density. From here, if I want to find out what is my charge in this small area, what is the charge in this, how much charge is there in the small area, that I can find by taking dQ is equal to rho into dV. Okay, now again, what will be the force experienced because of volume charge distribution at this point Q? Now basically this will be, what is at this point, it will be force experienced by this charge because of the small volume that we have considered, right? Volume of charges we considered. So that small force, not because of the entire sphere, but because of the small volume that we considered. Now that will be equal to, this will be equal to, we can say 1 by 4 pi epsilon naught, okay, Q naught into dQ. dQ is what? Rho dV by r square. The distance is r square into unit vector r cap. Alright, now this is again because of the small volume over here. For the entire volume, what we do? We have to integrate. So if you integrate dF over the volume, we get the force experienced by this charge because of that whole volume of that object, right? Now, because of that whole sphere, what will be the force experience at that point you can get, in case if you're taking a sphere, right? In this case, it will be, we'll take all the constant quantities out, which is 1 by 4 pi epsilon naught you can take outside, right? Then you will have integration rho, integrating over the volume V. Okay, rho divided by r square dV into r cap. Alright, now in case if you want to see for, okay, now this is for this is the force experienced by this charge because of this entire volume. What will be the electric field? Very simple, we have done this multiple times till now. Now force experienced is given, electric field will be force per unit charge. Force is we found the force to be Q naught divided by 4 pi epsilon naught, integrating over a volume V, right? And this is basically rho dV by r square into r cap. Now the whole of this divided by Q naught, right? Electric field is electric field because of volume charge distribution. Will be this whole of this divided by Q naught. So Q naught and Q naught will basically cancel. So we have done in the previous case, this will be 1. Okay, so this is my electric field at this point because of this volume. Now, in case if you're taking, in this case, if you want to find what is rho, right? In case if you're taking a sphere, right? Let's say the sphere, let's say the sphere has a radius r. If you're taking a sphere, if you're taking a sphere and the sphere has a radius r, okay, sphere has a radius r, in that case what will be rho? Rho is nothing but the how much charge, and this entire sphere has a charge, total charge in the sphere is q, okay. Then this rho is nothing but how much charges is there, how much charge is there, the volume charge density is given by how much charge is contained per unit volume, right? How much charge is contained per unit volume. What is the volume of the sphere over here? Charge, total charge contained is q. How much? What is the volume of the sphere in this case is 4 by 3 pi r cube. That will give you your rho. Okay. This is basically coulombs. Unit will be coulombs. In this case volume. So it will be 3 minus 3 per meter cube. Coulomb per meter cube. In case, what is the SI unit? SI unit of rho. This is SI unit of rho is basically coulombs meter cube. SI unit in this case of surface charge density, SI unit will be coulomb, in this case coulomb per surface. Surface is basically area, right? Area is basically meter square. Coulombs per meter square. Same time, if you want to find what is the SI unit of linear charge density, very simple. It is charge per unit length, right? Per charge per unit length. Charge per unit length is basically given as meter. Okay. Now, if you want to find out what is the right, now we have found all three cases, right? What is the volume charge density, what is your surface charge density, and also your linear charge density. So the total force, okay, the total electric field due to the continuous charge distribution, right? What will be the total electric field because of the continuous charge distribution? The total electric field because of the continuous charge distribution will be electric field because of the volume charge distribution, electric field because of the surface charge distribution, and electric field because of the linear charge distribution. Now, or this, you can write this equation basically as, we'll take all the commons outside. 1 by 4 pi epsilon naught is common. We can take that outside, right? Into volume, right? Integrating over the volume V, rho. Right, volume charge density is given by rho r square dV into r cap plus surface charge density is given by sigma okay, and linear charge density is basically given by lambda. Okay, so this is your continuous charge distribution. But in case if you're talking about the general charge distribution, it has more discrete charge values as well as continuous charge values, right? Discrete charge values is nothing but the electric field because of the particular amount of charge at a point in time. Okay, that we already saw. The superposition principle, we saw that equation, right? That plus this value gives you the general charge distribution. Right, so we are almost towards the end of the class. If you have any doubts, you can ask me. Otherwise, we will continue the rest in the next class. Okay, so once again, we have some upcoming plus batches, right? So for class 12, we are starting this plus batch from June 1st onwards. Right, and the mode of delivery will again be English. So for physics, we'll be meeting every Monday, Wednesday, Friday between 5:15 to 6:15. For math, Jyoti ma'am will be taking. For chemistry, Manisha ma'am will be taking. Biology, Lakshya sir will be taking. And the timings and the date is given. Okay. Now, similar to some of you asked about the class 11 as well. So for class 11, again the plus courses are starting from 8th June onwards, right? And we would be meeting every Tuesday, Wednesday, Saturday for physics classes. And again, Jyoti ma'am will be taking math and chemistry, and Lakshya sir for biology as well. And their timings for the courses is also given. Okay, so we have an interesting feature at Unacademy, that is the community feature. So you can follow any educators community. The link to my community channel is given down over here. So if you've seen the entire class, you can go to the community and there will be some pool questions, like pool style question asked on some questions about the continuous charge distribution. You can try attempting those questions as well. Now these you can follow any educators community that you like, and you will get updates about the upcoming classes. Okay, and like I do, like sometimes there will be some polls also, and you can share your feedback directly with the educators via polls as well. Okay, so that is one feature. Now other than this, we also have a feature called as Bucks Bounty. Now Bucks Bounty is in case if you're seeing any inappropriate content in the video, in the educator's video, okay, and if you're reporting them, then you will claim a prize. Alright, and also like and subscribe to the channel, right, so that any updates, the next upcoming classes updates are available, and also like and share. As well, click on the bell icon, so you would basically be getting the updates for the next classes. So in the weekend there would be 2 classes. So one class will be based on your numericals, another class we will continue from where we left. Right? So see you in the next class. If you don't have any more doubts, I'll be ending the session. So see you in the next class. Thank you for taking the session.